So when we last left our intrepid hero here, I had roughed out the openings in the sections of double-sided PC board or epoxy board to make the tube socket. This hole here, when I cut it with the hole saw, is 1.505 inches in diameter. So it was a 1.5 inch hole saw. It made it just slightly larger than 1.5 inches. So I've got 1.412, and I want to add 120 thousandths, between 115 and 120 thousandths. So I take the diameter of this 1.412 plus 0.115 equals 1.527 inches. So I'm starting with 1.505. I want to get to 1.527. That's only going to require a little bit of filing all the way around this opening to open it up about 12 thousandths all the way around, and I'll have the exact size that I need before to assemble the finger stock to the inside diameter of this opening, solder it in place, and test it out on the tube. So pretty confident that's a good number. 1.5, I think I started with 1.530, the first one that I made, and it was it was a little tiny bit loose. I felt I think I could have been a little bit tighter in the socket. So I'm going to go with 1.527, and we'll see how that goes. All right, so true to form, Numbskull here forgot to turn on his microphone, so he's showing you how to how I clamp the tube socket layer into the vise, and I'm pointing at the hole. I'm using the Dremel tool with a drum sanding bit on it to enlarge the hole, and when I do so, I discover that the removal of the material is very quick, so that when I pull it out, guess what? I actually got all the way to my target goal of 1.527 to 1.53 when I measured it. Fortunately, I did not overshoot the dimension that I was looking for, and ended up using that pretty much the way it is. So here I am showing off the soldering job that I did on the finger stock inside the opening. This was done against the tube. Unfortunately, I lost that clip. I apologize for that. But I think I did get a copy of that in my previous video. And now I'm going to take a picture of my handiwork that I'm so very proud of, and show you that in just a second. All right, there's the finger stock partially assembled with a couple of tack solder joints in it. And now I'm going to speed up the process and go through the finishing touches of doing all the soldering around it. Sparing you all the details, the nasty details. And here is the finished product with both sides soldered. And now I'm going to take the tube that I want to insert into it and show you how pretty that looks. And look at that, perfect fit. All right, so here I'm attempting to show you where I want the final resting position of the cathode layer of the tube socket to be. I'm lining it up on the edge of the cathode, right? And I'm showing it to you. Isn't that obvious? Okay. And I'm talking and I'm talking and I'm talking.
trying to explain. So here I am actually measuring after I've decided how high I want the cathode layer to sit. And what I measure here is 3/4 of an inch. Now, had I accounted for the thickness of the chassis, I probably would have made that 5/8 of an inch, but I ended up with 3/4, and even that's okay. And later on you'll see why. Unfortunately, I did not have 3/4 of an inch standoffs, but I did have 3/8 inch standoffs, and all I had to do was stack two of them on top of one another in each of the four corners, and I ended up with 3/4 of an inch.
Okay, my apologies for the missing audio in the previous clips. Let me check. Do I have a VU meter? Yay, I have a VU meter! Accidentally turned the switch off on my wireless mic because of the way I was wearing it. When I sat down, it pops the switch. Not the first time, and it probably won't be the last time, but this time it's on. So here we go. I'm going to do the same thing with my measurements on the tube socket for the cathode as I did for the grid. The grid is the larger ring that you see here, and I ended up making this opening 1.525 to 1.527 in diameter, and then assembled the finger stock to it, pushed the tube through it, and then soldered it in place, as you saw. The way I derived that number was the uncompressed thickness of the finger stock is 72 thousandths. You multiply that by 2 because you're going around both sides of the opening, so that's 144 thousandths uncompressed. I wanted that to be about 120 thousandths compressed total. So if you add 120 thousandths to the diameter outer ring of the diameter of the grid, you end up with 1.412 plus 0.120, and that came out to 1.527 or something like that. Yeah. So I'm going to do the same thing now for the cathode. All right. So my cathode in diameter is 1.708. I'm sorry, 0.708, 780 thousandths. All right. To that, I'm going to add 115 thousandths, and that will give me the diameter that I need to make the hole in this little metal plate here. So, where's my phone? 0.708 plus 0.115 equals 0.823. And the last time that I made this, I was shooting for 0.825. So this is a good number. 0.823 is the number that I'm shooting for. This hole I'm going to make with a large unibit. Okay, so I want 0.825. Yeah, and that's 0.875. So I will make it 13/16 of an inch in diameter to start, and then I will grind it out with my Dremel drum sander to the finished diameter of 0.823. So I'm just going to clamp this in the vise. Alrighty. So I'm just going to clean up the copper burrs with my Swiss Army knife. right, so remember the target is 0.823, somewhere between 0.823 and 0.825. And my actual right now is 0.805 to 0.810. Perfect. Perfect, perfect. So let me get my Dremel out again. This time I will use the smaller drum sander. I have two different sizes. Now, if experience has taught me anything from the last one, I don't want to push too hard because this thing takes off material very quickly. Ha, 0.825, look at that. Oh, not 0.830, no, 0.8, yeah, 0.825. It's a beautiful thing. So like last time with the grid contacts, I had to first take the finger stock and wrap it around the electrode and figure out how many sections of finger stock I need. As I indicated earlier, if I wrap it around like this, the finger stock edges are actually overlapping. But I get an idea of how many sections of finger stock I will need. And I'm going to put my finger right here and I'm going to count the number of sections that I need to make that full wrap all the way around the cathode. I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 sections. All right. So that leaves 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 sections that I do not need. And that 16 inches of this finger stock made 2 complete tube sockets, or will make 2 complete tube sockets if I'm successful. What I need to do now is, because I'm wrapping it in such a tight circle, I need to open up the spacing in between each of the fingers a little bit because they collapse in on one another as it rolls. So I need to take the what do you call it? Dremel, which I put away. Silly me. I need to take the Dremel again and grind away a little bit at these edges here so that they can roll in on one another without overlapping. The last time that I tried doing this, opening up the gap between the fingers in the finger stock, I tried holding it by hand while I was going through with the cutting disc, and the problem that I had was it would grab it and snag it and bend the fingers and distort the shape. So I'm going to try something a little different. I've got a thin piece of sheet metal, scrap sheet metal, that will rest against the thin part of the fingers that don't overlap one another, and use that to hold it against the soft anti-static mat that I have, and hope that it works. This is a first. I think it'll work. Seems reasonable. All right, I've got 7 fingers that I don't need, so I can start experimenting, and hopefully if it goes well, I can just keep going. Well, that looks good. Oh, hell yeah. All right. That should be all I need there. Take another picture and show what that looks like. Beauty. Now I can roll it in on itself on a very tight angle, and the contacts of the finger stock don't overlap. Wrap it around the cathode one more time to make sure I have the correct number. Aha, and you see, I actually had too many because it wouldn't rotate around itself. So now I know how many I need. Wait a minute, no. 1, 2, 3, 4, 5, 6, 7. No, I had the right amount. I just cut an extra groove here. Okay, so here we go. I've now committed myself to this. And let's see how it fits inside the opening. All right. Looks like I still have one too many fingers, which is okay. I would rather have too many than too few. So I'm going to break off one more. And now I will commit to inserting these in the opening. That's a beautiful thing right there. So as you can see, I have them reasonably centered in the opening. Now I'm going to put the tube through it to compress it against the edge, and I'll solder it into place like I did the grid. There we go. Oh, that's a nice snug fit. Beautiful. The cathode finger stock is in place. I'm going to tack solder it to the board and then complete the process and finish building this damn tube socket. Wow. Look at that. That is beautiful. So I'm just going to heat up the soldering iron, solder this one up, and then head up for dinner. And there's the skeleton for the new tube socket. Beautiful thing. All right, because I have to isolate the cathode from ground, and because this top surface mounts underneath the chassis through the opening and bolts to the metal chassis, I have to take and grind away the copper that I've drawn with a blunt, dull Sharpie using a circular guide. Actually, this is the cardboard tube that the finger stock came in, and I use that as my guide to draw the circle around the cathode opening. And I'm just using my Dremel to grind away all of the ink that I put down on this side. On the other side, I could not put a screw through it and keep the cathode isolated, but what I can do is I can use a what do you call it, a Forstner bit to score circles around each of the screw head openings, so that when I put the screw heads in here, there's no electrical contact to the chassis by way of the screw heads. That way the whole bottom of this becomes the cathode connection, except for the section that I isolate for the filament. We'll show you that in a little bit. Okay, that's not the prettiest, but it gets the job done. Now for the Forstner bit.
And true to form, I turned off my mic again when I was leaning over. So here I am showing you the Forstner bit that I picked from my set of Forstner bits. If you don't have any Forstner bits, get some. You won't regret it. Here I am putting the board against a piece of scrap wood, using the Forstner bit to drill out the circle areas to go around the screw heads, so that the screw heads don't cause the foil to short circuit to the chassis when assembled. And here I am showing you how the clearance is. I apologize for the autofocus. I thought I had autofocus turned on. Unfortunately, it was manual focus, so these close-ups are a little blurry. Sorry about that. And drawing the location where I'm going to be grinding off the bottom of the cathode
Here's
section
the completed tube socket
for the filament standoff.
You can get an idea of the detail on the filament contact. It's essentially a vertical PC board post with a standoff and the fuse holder clamp and a terminal lug on the back of this. It's isolated from the rest of the bottom of this by cutting a channel all the way around it, and then the etched copper that's on the board holds it in place. And that's it. Just to show you how the tube assembles into the socket, just like so. Easy peasy. Filament's engaged in the bottom, cathode is engaged in the middle, grid is engaged at the top. It goes directly to ground in the chassis. Grounded grid amplifier. And that's going to do it for this episode. almost from start to finish. You saw the first part when I cut the holes and roughed out the squares for the tube socket. And tonight I finished the holes, assembled the finger stock, put the layers together with standoffs, made the filament contact, and ended up with a GI-7B tube socket. Cool. That's all for now. Thanks all for joining me. Hope you had fun. As always, please rate, share, comment, and subscribe to my videos. Always hit that subscribe button, please. And peace, everyone.